Okay, in this example, we would like to, now we are using three-dimensional space, okay? And we are, let's say that we have two frames, 0 and 1. And let's say that at the beginning or initially, the two frames are exactly the same as each other or coincident with each other. And then we rotate frame 1 30 degrees counterclockwise about or around the z-axis. Okay, so we would like now to know the rotation matrix that takes a vector in frame 1 and projects it into frame 0, which is basically r1 to 0. So the way to do this is exactly the same as we did in the last example. We just need to find the projections of these frames into the projections of frame 1 coordinates into frame 0 coordinates. Okay, so we start with the first column, which is the x1 projections. Okay, x1 projections. So basically we have a sign here, I mean a 30 degrees angle with the x0 axis, okay? And we have here a right triangle. Let's see the different color here. Right triangle. And basically my x1 axis in the 0 frame is equal to this much, okay, and then this much, okay, added with this much, okay. So it has basically two components, and it doesn't have a z component. All of its components are in the x and y coordinates, okay, not the z coordinate, because the z coordinate is 0 in this case. So I can start with the z coordinate component and say 0 here, okay? And for the x coordinate here, the x coordinate, it's basically this component here, okay? Which is nothing but a cosine of 30, okay? Cosine of 30. So we have to find the sine and cosine. So you can say, well, you can use your calculator, that's fine. So cosine of 30, which is basically square root of 3 over 2, okay? And now sine of 30 is 1/2 right away, because you must know that sine square of theta plus cosine square of theta is equal to 1. So if I square this and subtract it, if I square this quantity here and subtract it from 1, I get the square of sine of 30. Okay, so what do? Basically, square root of 3 over 2 squared is 3 quarters. And if I subtract this from 1, I get my basically sine, okay, which is what? Which is nothing but 1 over 4. So this is the square of my sine, my sine. I need to take the square root of that, which is 1/2. Okay, 1/2. Next, I do the same for the y. So the y1, the y1 has two components again, one along the y-axis and another along the negative direction of x-axis. Okay, this is one component, and this is it. But it doesn't have any other component on the z direction. So the z is 0 as well here. Okay, so again, this is the same angle here, 30. Okay, because we rotate the whole frame about the z-axis using the same amount. Okay, for both coordinates. Okay, so along the x-axis, this one here, okay, is what? Negative sine 30, which is minus 1/2, and then the cosine is positive because it's basically along the direction of the y0, so it's square root of 3/2. Now the z, okay, is basically the same. Z1 is exactly coincident on Z0, because so basically the projections of Z1 onto Y0 and X0 are basically zeros. And basically the property that tells us that columns of rotation matrices are unit vectors necessitates that this must be a 1 here. Okay, so this is basically the rotation matrix that takes a vector in frame 1 and represent it in frame 0. I hope this is clear. Next, I'm going to discuss another perspective to look at the rotation matrices. Okay. Let me start another video and get back to you.